All right, we're going to be working on chapter 5, lesson 3, slope-intercept form. So what we're going to learn in this lesson today is how to write and graph linear equations in slope-intercept form and how to model real-world data with an equation in slope-intercept form. So vocabulary is slope-intercept form. So we're going to talk about what that is and what that looks like. So how is a y-intercept related to a flat b? So if you remember, y-intercepts are when your graph or your line crosses the y-axis on the coordinate plane, right? So when it crosses the y-axis, that is known as the y-intercept. So here's an example. It says a cellular phone service provides charges at 10 cents per minute plus a flat fee of $5 each month. So if I talk 0 minutes, they're going to charge me $5, and every minute is going to add on 10 cents, right? So if I talk a total of 7 minutes, they're going to charge me $5.70. So if I were to take these x and y coordinates and put them on a graph, it would look like this. And if you notice, here is my y-axis, right, when x is 0, it crosses the y-axis at $5, right? So this would give me an example of the slope of the line being 0.1, right, because it goes up 10 cents, right, zero point 0.1 or 0.10, 10 cents, crosses the y-axis at 5, right, $5. So the equation of this line would actually be y equals 0.1x plus 5, where again, 0.1 is the 10 cents per minute charge, and the 5 being the flat fee of $5. So we're going to get into this a little bit more. So we're going to go over this key concept here, right? The slope-intercept form of an equation. An equation in the form y equals mx plus b is in slope-intercept form. When an equation is written in this form, you can identify the slope and the y-intercept of its graph. So this is going to be a really big idea and concept that we're going to be using here and moving forward when we talk about graphing lines. So linear equations y equals mx plus b is written in slope-intercept form, where m is your slope and b is your y-intercept. So again, here's the equation. And so really important are pieces of information we need are m, the slope, and b, the y-intercept. So here's a model of what that looks like, right? Slope-intercept form, b being your y-intercept, so wherever it crosses on the y-axis, that's your y-intercept, and m being your slope, your rise and run. So let's look at what this might, how we might encounter this in a problem. It says write an equation given slope and y-intercept. So if it asks me to write an equation of a line whose slope is 3 and whose y-intercept is 5, I can use the slope-intercept form of the equation, right? Y equals mx plus b. You probably want to write this down and memorize it. So really, all I need to do in order to write the equation of this line is to put in the slope and the y-intercept, which it clearly gives me right here, right? So I'm going to go ahead and take my slope and my y-intercept and substitute them into the equation. So 3 is my slope, 5 is my y-intercept. So my equation would be y equals 3x plus 5, right? I put the slope in the right spot and I put the y-intercept in the correct spot. So let me go back a second. So this is kind of the basic way that we can create a slope-intercept form of an equation if we have the slope and we have the y-intercept. So what about if they want me to write an equation in slope-intercept form, but now they're going to give me 2 points. So they give me this graph here, and they're like, hey, here's the line, and it goes to the point 0, 3, and the point 2, -1. So if I know these 2 points, well, I know that I need the slope and the y-intercept of this line. Well, first thing I want to do is I probably want to find the slope, right? I need the slope. And you guys know how to find slopes between 2 points, right? We can use the slope formula, right, where we subtract the y values from each other over subtracting the x values from each other. So I can go ahead and use this as my first point. This is my second point. And I can go ahead and substitute those values in. So -1 minus 3 over 2 minus 0. Simplify it becomes -4 over 2, right? -1 minus 3 is -4. 2 minus 0 is 2. And then I simplify it. -4 over 2 is just equal to -2. So now I know my slope is -2. So I have a slope, right? So the next step is, well, I know that the line crosses the y-axis at 0, 3, right? So my y-intercept is 3. Well, now that I know my slope and my y-intercept, I can write my equation. So here's the slope-intercept form of the equation. And again, all I'm substituting in is the slope and the y-intercept. So again, my slope is -2, my y-intercept is +3, and that would be the slope-intercept form of this equation, right? So the equation of the line is y equals -2x plus 3. One advantage of the slope-intercept form is that it allows us to graph equations very quickly. So here's an example. Well, here they give you a graph, or they ask you to graph the equation y equals -2/3 x plus 1. So here they give me the equation and when they want me to graph it. Well, look at the equation. It is in slope-intercept form. So I can read what the slope is and I can read what the y-intercept is. So let's go through these steps. Here's my graph. And I'm going to go ahead and take this equation and I'm going to graph my line. So I'm going to start off by step 1. I'm going to put a point on the y-intercept. Since I know the y-intercept is +1, that would be located right up here, right? There's my y-intercept. It crosses the y-axis at +1 at 0, 1. The step 2 is I know my slope is -2/3, right? So I can rewrite it as just a rise over run. So I'm going to go down 2, run 3. So I'm going to go down 2, and then to the right 1, 2, 3. And then that would be my second point. So now I have 2 points. I have my point for my y-intercept. I've now counted the slope, the rise, and the run, put my second point, and now I can go ahead and draw my line. So I'm able to take an equation in slope-intercept form and pretty quickly graph it by plotting the y-intercept, counting the slope, which plots, and drawing my line. But what if we're asked to graph an equation in standard form? Well, what if they give me this equation here? It said, hey, graph 5x minus 3y equals 6. Well, I wish it was in slope-intercept form because that would make it easier. Well, we can. We can make this into slope-intercept form. Remember, it's y equals mx plus b. So I can take this equation and I can solve it for y. I can get y all by itself, right, by using our skills of solving equations. So let's take this original equation and I'm going to solve for y. I'm going to start off by subtracting 5x from both sides, right? I want to get rid of this right here. So I minus 5x from both sides, which leaves me with -3y equals 6 minus 5x. And then I'm going to go ahead and I'm just going to rewrite it really quick. I can move this -5x to the front and this +6 to the back because 6 minus 5x is equivalent to -5x plus 6. The main reason why I did that is now look, I can start to see the structure of y equals mx plus b take shape. The one last thing that's missing though is y is not by itself. So I got to finish solving for y. So how do I do that? -3 times y, the opposite of multiply by -3, divide by -3. So when I divide both sides by -3, then I have to simplify. So this left side of the equal sign would become y, and then I need to divide both of these by -3, so -5/3 x divided by -3, +6 divided by -3, and then simplify, right? This becomes y. This can just be simplified as a negative divided by negative is a positive, so just +5/3x. And then 6 divided by -3 is -2. So this would be the slope-intercept form of this equation. Y equals 5/3 x minus 2. So now it's in slope-intercept form. Now I can take this equation, right? I've simplified it. I can take this equation and graph it just like I did in the last problem. All I need to do is utilize the slope and the y-intercept. So here's my graph. So I'm going to start with the y-intercept. I know the y-intercept is at -2. So that means on my y-axis, I'm going to go down 2. And it would be at this point right here that my line's going to cross the y-axis, right? 0, -2. And then the next step is I'm going to count my slope. Well, I know my slope is 5/3. So that means I'm going to go up 5. 1, 2, 3, 4, 5. And then I'm going to go over 3. 1, 2, 3. And that would be my next point. So now that I have my 2 points, now I can go ahead and draw my line, and it would look like that. Okay, so let's look at another example. So in example 5, it wants you to write an equation given 2 points. So let's go ahead and write an equation of a line through these 2 points. So here I have the point -2, -3, and the point 1, -3. Well, if I take those 2 points and I were to find the slope between those 2 points, right? The change in y's coordinates over the change in x coordinates, I would get 0 because I would get -3 minus -3, which is 0, and I would have -2 minus 1. So clearly I can see that the line crosses uh, the y-intercept at -3. So there's my y-intercept there. And finally, I'm going to go ahead and write the equation. So again, this is my slope-intercept form. Well, we found our slope. Our slope is 0, which makes sense. If it's rise over run, it doesn't go up at all. All it does is run. So my rise would be 0, and my run can be whatever number you want it to be. So if my slope is 0 and my y-intercept is -3, it would look something like this. Y equals 0x plus -3. Well, I would want to make sure I simplify this. What is 0 times anything? 0 times anything is 0, so 0 times x is 0. And then 0 plus -3 would just be -3. So the equation to a horizontal line, right, a flat horizontal line, would be y equals -3. Y equals its y-intercept. So this would be the equation to this line. So whenever you run across a horizontal line, right, with a slope of 0, it's always going to have the same structure. Y equals whatever the y-intercept is, -3. All right, well, thank you guys for watching, and let me know if you guys have any questions.